For this experiment, we require ethylene diamine tetraacetic acid, magnesium chloride, EBT indicator, and buffer solution having pH 10. Let's first prepare the 0.02 molar EDTA solution. For this, weigh 0.745 gram of EDTA. Transfer this EDTA into the beaker. Dissolve in minimum quantity of water. Add 0.2 gram of magnesium chloride and stir the solution to get clear solution. Dilute this solution into the 100 ml standard measuring flask up to the mark by using distilled water to get 0.02 molar EDTA solution. Fill the prepared 0.02 molar EDTA solution into the burette. Now you are provided with standard measuring flask bearing your table number containing unknown sample solution of calcium ion. Dilute the sample solution by using distilled water up to the mark. Pipette out 10 cm³ of diluted sample solution in the conical flask. Add 1 test tube of pH 10 buffer solution to the same conical flask. Then add 2 to 3 drops of EBT indicator. Titrate the content of the flask with 0.02 molar EDTA solution till the endpoint becomes wine red to blue. Take 2 more readings and record the observations in the observation table. Here for this sample, the constant burette reading is 14.2 cm³. Do the calculations. 10 cm³ of diluted solution required 14.2 cm³ of 0.02 molar EDTA. Therefore 100 cm³ will require 10 into 14.2, that is 142 cm³ of EDTA solution. By stoichiometry, 1000 cm³ of 1 molar EDTA is equal to 40.08 gram of calcium, and therefore 10 cm³ of diluted sample solution contains 14.08 into 10 into 14.2 into 0.02 upon 1000, which is equal to 0.11 gram of calcium. The true value for the given sample is 0.11 gram, and hence percentage error observed for this sample is 0%. Hence the results are amount of calcium present in the given sample is 0.11 gram and percentage error is 0%.